In this video, we're going to see trigonometric equations that have one solution. Of course, as you can see in the example, you are asked to solve for theta between 0 and 360. In the three parts A, B, C, you have sine equation and cosine equation. We have chosen this interval so that theta takes all the values between 0 and 360, and 360 is the period of sine and cosine. So it's on the period range for the values of theta. Okay, so we start with part A. Sine theta equals 1. We look at this graph here. This is the graph of sine theta. As you can see, all along the graph, there is only one point that has a sine equals 1, which is this point here. Okay, so the sine equals 1. And this point happens when theta equals 90 degrees, and this is the only solution for the equation in part A. Okay, so this is how you write your solution for part A. Sine theta equals 1, theta equals sine inverse, this is the inverse function of sine, for 1, and theta equals 90. Right. No more solutions between 0 and 360. And 360, as you can see, is the period of sine. Now, we go to part B. In part B, we are asked to solve cosine theta equals 1. As you can see here, cosine theta equals 1 happens here when theta equals 0, and happens here as well when theta equals 360. However, we accept only 0. Theta equals cosine inverse 1 and theta equals 0 degrees. Why I discarded 360? Because in the question, look at the interval. Theta takes the value between 0 and 360, inclusive 0 but excluding 360. There is no equal here, so we cannot accept the value 360. So it's a unique solution, as you can see. The only solution on the interval in the question is 0 degrees. Okay, now we go to part C. In part C, we are asked to find the solutions of cosine theta equals minus 1. Now, on the graph, as you can see, cosine theta equals minus 1 at one point only. And that happens when theta equals 180 degrees. So cosine inverse of minus 1 is 180 degrees. And no more solutions between 0 and 360. So this is another one solution case. Okay, one more example. It's about the tangent equation. A tangent equation always has one solution between minus 90 and 90. Which is actually the length that is 180 degrees, the length between minus 90 and 90. Here's the graph of tangent theta. Okay, as you can see, for any values of y, we get only one point on the graph that has that value as a tangent. This is an example. So for theta between minus 90 and 90, the equation tangent theta equals 1. As you can see here, this is our 1 for tangent, and it is the y coordinate of this point, and the point has an x coordinate pi over 4, which is 45 degrees. So there is only one solution, as you can see, between minus 90 and 90, which is pi over 4. So the tangent has one unique solution. For tangent theta equal 1, tangent theta equal tangent inverse of 1, and theta equals 45. And by the way, the tangent equation, whatever the value given here, you get one solution. Of course, between minus pi over 2, or between minus 90 and 90. These are the three examples for a unique solution, as we can see. Just remember them, and thank you very much.